Hello guys, how are you? So today we are going to talk about the very latest one topic and not the latest one, but yeah, so many organization peoples and the interviewers are also asking the questions related to that and it's related to the rack system. So once you make the chunks of your data, once you store all those embeddings of chunks in a specific vector store, so after that how you are going to retrieve that chunks. So many people are just utilizing like they will convert the query into the embeddings and they will check the cosine similarity or others like distance material to distance or Euclidean distance and based upon that actually they will just give me 1 minute and based upon the cosine distance they will actually try to retrieve those what we can say chunks, but you know the return chunks either means if you mention the size of that return chunks like top k20s or top k10, but you never know that like the retrieved chunks results are either related to query or not, or either they are containing all the information related to that query, or they are just making irrelevant information. So that's why two matrices are coming into the markets. Like one is the context precision and another one is the context recall. Okay. And apart from that, also you need to make some re-ranker technique. So you will, many of you have heard like what is re-ranker, how it's re-rank the results. So re-ranker is nothing but based upon your query, whatever chunks are returned from that vector store, so it will actually re-rank those chunks according to the context of that query. So based upon this query similarity, it will try to arrange those chunks and it will return only top chunks. So precision will give the importance like how many you have written the top 10 chunks. So out of top 10 chunks, how many are relevant to the that user's query, and retrieval will going to focus on like does those retrieved 10 chunks containing all the detailed information related to that query or not. So in the re-ranker we will going to see like cohere re-ranker, which is the in the news and so many people are utilizing it. So cohere re-ranker is nothing but the cross encoder model where actually at a time query as well as that documents or chunks are going passed to the encoder models, and based upon that queries attention scores and documents attention score, it will try to retrieve those topmost chunks into the output, and it will going to give means it will going to rearrange those results. So that's why that re-rankers are very necessary, but they have also some disadvantages. If you utilize that core ranker and if you have so many lakhs of data or so many number of chunks are stored into the vector store, so it will take huge number of times, it's required huge number of GPUs, and if you are utilizing that core APIs then it will have a huge cost. So you can go towards like if you want to focus on that fast retrieval with little bit compression on the accuracy, then you can go towards that BM25, which is based upon the pass embedding and it's a TF-IDF based. So it will help for full means it will not require too much memory, or else you can go towards the another one is the colbert. So it's a contextualized later BERT embeddings where colbert will going to keep those attention scores and document scores into the documents or in the memory stores, and as unlike the cross encoder model like coher, it will going to process all documents at a times without taking huge time or huge number of memories. So apart from that, Colbert or Core re-ranker, there are other re-ranker methods given by Azure AI Search, which is based upon the semantic re-ranker. It's also a cross-encoder type re-ranking method, and it will going to arrange those retrieved chunks based upon the query similarity, meanings, and keywords, where you can utilize it as a hybrid search, and in that hybrid search you can also utilize like semantic search for re-ranker, then keyword search for that specific keys, and vector search also. So it's a combination of all those three, and based upon that, yeah, definitely your results will be retrieved. Once your results are context is retrieved, then we are passing to the retrieve to the generation models for the GPT or any LLM model, and at the last that LLM model will going to give you some results. So at the last you can evaluate those results by using any framework like DP evaluation or like Ragas frameworks, where you can see is like how it is giving the relevancy, faithfulness, then hallucination, and also you can do evaluate it by using the manual results. So I hope I have just covered in the very short and depth also manner, like how those re-ranker, core re-ranker works, how Colbert's works, how Azure semantic AI search works and how you can integrate. There are various frameworks like you can utilize in Azure AI search, or you can utilize LangChain frameworks, or also you can utilize that Lemma index, or where you can utilize and pass all those importers library and pass those into the your retrieval stores. So always try to check all those embeddings or methods in your rack systems, and let's see how those results are improved or not. And please comment, means give me some comments. And if you have any questions or doubt, please try to ask me. Do not feel shy. And please give me the feedback on the videos also. So I'm making those. So have a good day. We will talk in the next series. Thank you. Bye bye.